When people hear the phrase 4GB RAM versus 16GB RAM, the assumption is almost automatic. More RAM means more power, better performance, smoother experience, and overall superiority. It sounds logical, and in many cases, it is. But what happens when you bring operating systems into the equation? What happens when you compare 4GB RAM running Linux versus 16GB RAM running Windows? Suddenly, things are not so straightforward anymore, and that's where the shocking truth begins to unfold. Imagine two computers sitting side by side. One has 4GB of RAM running a lightweight Linux distribution. The other has 16GB of RAM running Windows. On paper, the second system should dominate in every possible way. It has 4 times the memory, likely newer hardware, and a modern operating system designed for broad compatibility. But when you actually start using both systems side by side, something surprising happens. The Linux machine feels faster, more responsive, and more efficient in everyday tasks. The Windows system, despite its higher specifications, sometimes feels heavier, slower, and more resource-hungry. This is where the core difference lies, how each operating system uses the available resources. Linux is built with efficiency in mind. It was designed to run on everything from powerful servers to extremely low-end hardware. That means its core philosophy revolves around minimalism and control. You only run what you need and nothing more. Windows, on the other hand, is designed for maximum compatibility, user-friendliness, and a broad ecosystem of applications. But that convenience comes at a cost, and that cost is resource usage. When you boot up a typical Linux system, especially something like a lightweight desktop environment, you might see RAM usage as low as 500 mAh to 1 GB. That means out of 4 GB, you still have around 3 GB available for applications. Now compare that to Windows. A fresh Windows installation can easily consume 3 GB to 5 GB of RAM just sitting idle. That means even with 16 GB installed, a significant portion is already gone before you even open a single app. Now think about everyday usage. Opening a browser, watching videos, writing documents, or doing light editing work. On Linux, these tasks feel smooth because the system itself is not fighting for resources. Everything you do is directly benefiting from the available RAM. On Windows, however, background services, updates, telemetry, antivirus scans, and system processes are constantly running. They compete with your applications for memory, CPU, and disk access. So even though you have more RAM, a large chunk of it is constantly being used by the system itself. Another important factor is how each system handles multitasking. Linux is known for its efficient memory management. It uses techniques like caching and swapping intelligently, ensuring that active applications get priority. Even with limited RAM, Linux can handle multiple lightweight applications surprisingly well. You can have a browser, a code editor, a terminal, and a media player open, and the system still feels responsive. Windows, on the other hand, tends to rely heavily on virtual memory when RAM usage increases. That means it starts using your storage drive as temporary RAM, which is significantly slower. This leads to lag, stuttering, and delays, especially if you're using a traditional hard drive instead of an SSD. So even with 16 GB of RAM, if the system is poorly optimized or overloaded with background tasks, performance can drop dramatically. Let's talk about software optimization. On Linux, many applications are designed to be lightweight and efficient. You have alternatives for almost everything, from text editors to media players that consume minimal resources. On Windows, many applications are built with the assumption that hardware is abundant. Developers don't always optimize for low resource usage because most modern systems have plenty of RAM and processing power. This leads to bloated software that consumes more memory than necessary. Gaming is one area where Windows still has a clear advantage, but even here, things are changing. Linux has made huge progress with compatibility layers and performance improvements. But if you're comparing 4GB Linux to 16GB Windows specifically for gaming, Windows will likely perform better in most modern titles. However, for casual gaming or older games, Linux can still deliver a surprisingly smooth experience even on limited hardware. Another aspect that often goes unnoticed is system control. Linux gives you full control over what runs on your system. You can disable unnecessary services, remove unwanted packages, and fine-tune performance to match your needs. Windows, while improving in customization, still limits how much control you have over system-level processes. There are always background services you can't fully disable, and updates can sometimes run at inconvenient times, consuming resources when you need them the most. Security also plays a role in performance. Linux is generally considered more secure by design, which means it doesn't rely heavily on resource-intensive antivirus software. Windows, being the most widely used operating system, is a bigger target for malware. As a result, it runs constant security checks and background scans, which consume CPU and RAM. This adds another layer of resource usage that Linux systems often avoid. Now let's consider real-world scenarios. A student using a 4GB Linux laptop for browsing, writing assignments, watching lectures, and light coding will likely have a smooth and frustration-free experience. The same student using a 16GB Windows machine might still experience slowdowns if too many background processes are running, or if the system is cluttered with unnecessary software. A developer working on Linux can run lightweight tools, use terminal-based workflows, and manage resources efficiently. On Windows, development environments often require heavier IDEs and additional services, which consume more memory and processing power. Even in professional environments, Linux is widely used on servers and workstations because of its efficiency and stability. It can handle heavy workloads with fewer resources, which translates to cost savings and better performance per unit of hardware. But let's not ignore the other side of the story. Windows offers a level of convenience and compatibility that Linux still struggles to match in certain areas. Many professional applications, especially in fields like video editing, graphic design, and engineering, are optimized for Windows. In these cases, having 16GB of RAM on Windows can make a significant difference, especially when working with large files and complex projects. User experience is another factor. Windows is designed to be familiar and easy to use for the average person. Everything works out of the box, and most software is readily available. Linux, while improving rapidly, still requires some learning and adjustment. For someone who just wants a plug-and-play experience, Windows might feel more comfortable. So what is the shocking truth? It's not that 4GB is better than 16GB, it's that raw hardware specifications don't tell the whole story. The operating system, software optimization, and resource management play a huge role in determining actual performance. A well-optimized system with fewer resources can outperform a poorly optimized system with more resources. This challenges the common belief that upgrading hardware is always the best solution. Sometimes the real improvement comes from optimizing what you already have. Switching to a more efficient operating system, removing unnecessary software, and understanding how your system works can make a bigger difference than simply adding more RAM. In the end, the comparison between 4GB Linux and 16GB Windows is not just about memory, it's about philosophy. Linux focuses on efficiency, control, and minimalism. Windows focuses on compatibility, convenience, and a broad ecosystem. Both have their strengths and weaknesses, and the best choice depends on your specific needs and priorities. But if there's one takeaway from this comparison, it's this: more isn't always better. Efficiency matters, optimization matters, and sometimes a system with fewer resources can deliver a better experience simply because it uses those resources more intelligently. That's the real shocking truth that most people don't expect until they see it for themselves.